Alright, so 7.1 notes, completing the square. So our steps are laid out right there. Okay, those are the 5 steps. We're just going to follow those steps straight through. As I already said, we're going to go through example 1, and then we're going to look at the third example. We're actually going to skip example 2. But we're just going to go step by step right through those steps to get our problem solved. So step number 1 was transform the equation so that the constant term is alone on the right side. So C, or our constant term, is this plus 3. So I'm going to subtract 3 from both sides, and that gives me a squared minus 5a equals negative 3. Now the reason why we're doing this is because we are trying to get this to be a perfect square trinomial on the left side, so that way we can take the square root of both sides, okay, and get rid of that a squared and solve for a. So now that we've done step 1, step 2 says if the coefficient of the second degree term is not equal to 1, then divide both sides by it. Well, our coefficient was 1, so we don't have to worry about step 2. Step 3 says add the square of half the coefficient of the first degree term. So if we take this 5 this negative 5, okay, and then we put it over 2a, which is 2 times 1, and square it. So b is our negative 5, and we put it over 2 times a, and then we square it. And we're going to add that to both sides. What happens when we square a negative number? It's going to become positive. We'll get there here in a second, but right now we're just going to leave it like this. So what that leaves us at is a squared minus 5a plus this negative 5 over 2 squared equals this negative 3 plus the negative 5 over 2 squared. Okay, now we can combine these two terms if we get common denominators. So this is actually, right, 25 over 4 when we do, right, when we square that out. And then when we look on this side, right, to make this over 4, we would have to multiply by 4 over 4. So that would be a negative 12 over 4. So that means this is just going to equal negative 12 over 4 plus 25 is a positive 13 over 4. On this side, right, this would be a squared minus 5a, and then plus that same 25 over 4. Now, since we built this to be that perfect square trinomial, we know that we can factor this down to a minus, okay, our 5 over 2, because this is our b over 2a, and then it's just squared. And if you want to double check and make sure that you're doing it correctly, you can always multiply those back out, write the a minus and double check it. So now once we get to this point, right, we could take the square root of both sides. Once we take the square root of both sides, right, the right side needs to become a plus or minus. So this is a minus 5 halves equals, and then we have this plus or minus the square root of 13 over 4. But now we can actually take the square root of this 4. So this is plus or minus the square root of 13 over 2, right? Because the square root of 4 is 2. And then, so a minus 5 halves. So now we want to solve for a. So we just add 5 halves to both sides. And we get a equals 5 over 2 plus or minus the square root of 13 over 2. Okay, now these are both over 2, so you could write this as a equals 5 plus or minus the square root of 13 all over 2. Any questions? Alright, so like I said, we're going to skip to the third one. Now, this this one takes some writing out, okay? And it also, with this particular problem, right, we're going to solve for x, and it's still not going to quite look like the quadratic yet. We're going to have to do some moving around of things to get it to that. So with this one, I like to say that it's helpful to know where we're trying to get, right? And where are we trying to get? We're trying to get to our quadratic equation, which is going to be that negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what we want to get to eventually. That's what we're looking to get our x equals. It's just going to take some finagling to get there. So as we work our way through, right, we go through our steps. Our first step is divide everything by a. So if I take my ax squared plus bx, oh, sorry, we got to subtract c first. Yep. I always just do that step. I forget that it's written out as step 1. Okay, so step 1 was subtract the constant from both sides. Step 2 is to divide everything by a. So now we have x squared plus b over ax equals negative c over a. Okay, now, right, we're supposed to add that b over 2a, right, squared. So now we add our b over 2a squared, so plus b over 2a squared. So that gives us x squared plus b over ax plus b over 2a squared equals our b over 2a squared minus c over a. Now, since this has been written to give us this perfect square trinomial, this can come down to x plus b over 2a squared. Okay, and then on this other side, right, we're just going to be left with this b over 2a squared minus c over a. Since this is squared now, we can take the square root of both sides, and that gives us now that x plus b over 2a equals the square root of b plus 2a squared minus c over a. And at this point, right, that became plus or minus because we took the square root. So now we need to solve for x. So we need to subtract b over 2a from both sides. So then we found that x equals the negative b over 2a plus or minus the square root of b over 2a squared minus c over a.
Why is that exponent still there in the square root?
Right here?
Yeah, like why is there?
Because remember, you can't, like, the square root of a squared minus b, or of a squared minus b is not the square root of a minus the square root of b. So
even if it's there, you still can't get rid of it, even though it's under a...
Right, because we have this addition or subtraction. Anytime you have that addition or subtraction, you can't just get rid of that square root sign. So we solve for x, but this is a heck of a mess, isn't it?
Yeah.
Right? So how do we get rid of this heck of a mess? Well, the first thing we want to do is make it so they have the same denominator so they can be added together. Which means I have to multiply the second half of this, right? That's like that being over 1. So if I multiply it by 2a over 2a, that then allows me them to have the same denominator. So that gives me x equals negative b plus or minus the 2a times that square root of b minus 2a squared minus c over a, all divided by 2a. Now we have a couple of things that are a little bit, yes, you could call them odd maybe, right? We want to get this dealt with, right? The fact that we have this b squared over 2, or we have this b over 2a squared. Okay, we also, this 2a out in front, right? We want to get that inside here. So 2a, right, equals the square root of 2a squared, right? So if 2a equals the square root of 2a, I could rewrite this as x equals a negative b plus or minus the square root of 2a squared times, in parentheses, okay, I have this, I'm going to actually do this out now, so this is going to be b squared over 4a squared minus c over a, and then that's all over 2a. And then this gives us a situation where we have like the square root of a times the square root of b, which equals the square root of a times b. So then this is negative b plus or minus the square root of, and 2a squared is just 4a squared, right? Because it's the quantity squared. So 2 squared is 4, and then a squared. So that's going to be 4a squared times b squared over 4a squared minus c over a times 4a squared. Right? Because we have to distribute it to each part of this to make it so it doesn't have to all stay in parentheses. And then that's all over our 2a. So notice how this 4a squared cancel each other out. And at this point, I'm left with just this b squared for my first term. My second term, I take away 1a because it's divided by 1a, and I'm left with 4 times a times c, all divided by 2a. And look at that. We came up with a quadratic equation. Now, instead of making you do this every time, right? We're just going to use the quadratic equation. I'm not going to expect for you to start over here with every problem and work your way to this, right? We see this exist, we know it exists, now we're going to use it, okay? So as we move into the 7.2 part, we're just going to use this equation. So every one of these problems can be written in the form ax squared plus bx plus c equals 0. So one of the things that I always advise students to do is identify what their A, their B, and their C are as soon as they realize that they're going to be using a quadratic equation. Because as soon as they identify those, it becomes easier, right, to make sure we put the right things in the right spots. So if we go through here, right, A is our coefficient for our x squared term would be 5. B, which is the coefficient of our x squared, or of our x term, which would just be 4. And then C is the constant that's at the end. So once I've identified these, I can use this equation right here to get our answers. So this would be a negative 4 plus or minus the square root of 4 squared minus 4 times 5 times negative 2, all divided by 2 times 5, because that's our A value. Now, from this step to the end, right, a lot of kids will skip a bunch of steps. And that's okay, just as long as you do it correctly. So this is negative 4 plus or minus. I'm going to show out the steps. So 4 squared would be 16. We have minus a negative, so this is going to go to plus. 4 times 5 is 20, times 2 is 40. All divided by 2 times 5 is 10. So negative 4 plus or minus the square root of 56 over 10. 56 breaks down to 4 and 14. So that means that's negative 4 plus or minus 2 root 14 over 10. And then is there anything that we can take out of all of those? Yep, we could take a 2 out of those, right? So if I divide each piece of this by 2, top and bottom, that gives me negative 2 plus or minus the square root of 14 all over 5. Okay, so if you're told to leave it in radical form, this is what radical form is, right here. Okay? Now, if that was the square root of 16, right, and so you could get 4, right, you would be expected to get each answer separately. Okay, because of the fact that we're leaving this one in radical form, we just leave it like this. If it asked for the answers in decimal form, then you would actually have to do the plus, do the minus with the decimal approximation, and then get 2 separate answers in the end. Okay, for number 2, same idea, right? A equals 4, B equals negative 5, C equals 3. So this is a negative negative makes for a positive 5 plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So 5 plus or minus the square root of 25 minus 48, because 4 times 4 is 16, times 3 is 48, all over 8. So that's 5 plus or minus the square root of a negative 23 over 8. As soon as we see we have a negative, right, we know we're dealing with imaginary numbers. So we pull that I out in front, and that's 5 plus or minus I root 23 over 8, right? And we said that we want to write these as the complex number that has the real part of it and then the imaginary part of it. So that would be 5 over 8 plus or minus the square root of 23 over 8i. Okay, the next part of this is going to be dealing with some story problems. And so again, we're going to set up systems of equations, but this time we're going to end up with ones that we can't just set equal to 0. So it says 2 positive real numbers have a sum of 5 and a product of 5. So x plus y has to equal 5, and x times y has to equal 5. So I could solve for one of those, right? So if I subtract x from both sides, that would give me y equals 5 minus x. I can then take this value and insert it in for my y. So x times 5 minus x has to equal 5. So if I distribute the x through, 5x minus x squared has to equal 5. So now I need to get it set equal to 0. So I want my x squared to be positive, so I'll add x squared to both sides, and then I have to subtract this 5x from both sides. And that gives me 0 equals x squared minus 5x plus 5. Now, normally we would try and factor this, but I'm just going to tell you this is not factorable. Okay? It doesn't work. So now we can do our a equals 1, our b equals negative 5, c equals 5. And then I want to do the quadratic equation with this. So negative negative 5 is positive 5, plus or minus the square root of negative 5 squared, which would be 25, minus 4 times 1 times 5. So 4 times 1 is 4, times 5 is 20. All over 2 times a, but 2 times 1 is just 2. So then that's 5 plus or minus the square root of 5 over 2. Now, with these types of problems, one of the things that's kind of interesting, right, is that you're going to get your x and your y. You'll get x equals one thing and y equals the other, and it's going to be the plus and the minus, right? So when you do this, we're just going to stick with the positive, with the plus, okay, when we go to find what our y would have to, what our x would have to equal. Now we solve for x, we need y, right? So this was x equals, this was x equals. Okay, so now if x equals this, so our x we're going to say is our 5 plus root 5 over 2. So then y would have to equal 5 minus this 5 plus root 5 over 2. Right? So to get this to be able to subtract that out, y would have to equal, that would be 10 over 2. Right? So then when we subtract the 5 plus root 5 over 2, so this would be, right, you can write that all as one fraction now. So 10 minus 5 plus root 5 over 2. And that would just give us 10 minus 5 is 5 minus root 5 over 2. So see how our two answers, right, are going to be the 5 plus root 5 over 2 and 5 minus root 5 over 2. So you're going to get the same answers. So those two are the two answers. So you have 5 plus root 5 over 2 and 5 minus root 5 over 2. Okay, those are the two that it needs to be. Okay, and the next problem they talk about it being dimensions, okay, of a jewelry box. So again, right, the two answers you get, those are going to be the two different possibilities that x and y have. So on this one it says the volume of a rectangular jewelry box is 4 centimeters, or that is 4 centimeters in height, is 136 centimeters. So I always like to draw my jewelry box. I know I'm not a great artist, but we do our best. Okay, and it tells us our height is 4. We don't know the perimeter dimensions of the base, so we're just going to call them x and y. Well, we know that our volume has to equal 136, and we know that our volume has to equal 4 times x times y, because volume is length times width times height. So that means 136 has to equal 4xy. So if I divide both sides by 4, I get that xy has to equal 34. Okay. On the other hand, we're told that our perimeter is 24, and we know that a perimeter has to be 2 times the length plus the width. So our 24 perimeter has to equal 2 times our x plus y. So if we divide both sides by 2, we get 12 equals x plus y. So here, right, we're getting to that same spot we were at on the last problem. So if we, subtract x from both sides, right, you get 12 minus x equals y. And then here we have our 34 equals x times y. So again, we can put this in for this y. So 34 equals x times 12 minus x. So distribute, 34 equals 12x minus x squared. Again, right, we want this to have a positive x squared. So we're going to add x squared and subtract 12x to both sides. And that gives you x squared minus 12x plus 34 equals 0. And then at that point, right, we would see if we could factor it. Well, we can't. It's not one that you can just factor down. So then that means we have to do the quadratic. So a equals 1, b equals negative 12, c equals 34. So negative 12 is a positive 12, plus or minus the square root of, well, you have 12 squared, which is 144, minus 4 times 1, which is 4, times c, which is 34, which gives us 136, all over 2 times 1, which is just 2. So then that gives us 12 plus or minus the square root of 8 over 2. But 8 is really 4 and 2. So this is 12 plus or minus 2 root 2 over 2. And see how I can take 2 out of everything, the 12, the 2, and that 2. So we divide top and bottom by 2. And that gives us 6 plus or minus the square root of 2 is what our x equals. So x can be the plus or the minus, and y is just going to be the other one. So our dimensions are going to be 6 plus root 2 by 6 minus root 2. And I mean, technically, right, those are centimeters because we were given our measurements in centimeters. And then last but not least, okay, we're going to look at number 3. Again, one where it takes a nice drawing is super helpful on it. Okay, it says a 5 by 7 photograph. So we start off with a 5 by 7 photograph. 5 by 7. Okay, surrounded by a frame of uniform width. So remember, uniform means, right, the same. So I draw a nice little, right, and each one of these is that same width. So we're going to identify that width as being x. Okay, we know that, and then it says the area of the frame equals the area of the photograph. Well, the area of the photo, right, is 5 times 7, or 35. And this is square inches, right? So that means that the area of the frame, right, has to be the same. So it also has to be 35 inches squared. So the total area, when I add those two together, right, has to be 35 plus 35, or 70. Now I know that my length across, or my width here, right, is going to be this 5 plus there's x on that side and x on that side, so that's 5 plus 2x. Okay, the length of this is going to be this 7 plus the x on both sides, so 7 plus 2x. So then I know that my 7 plus 2x times 5 plus 2x has to equal 70. Right? Because the area of the entire thing has to equal these two measurements multiplied together. So then if I actually go through and I FOIL this out, okay, that's going to give me that 35 plus 14x plus 10x plus 4x squared equals 70. Well, I know I want this equal to 0, so I'm going to subtract 70 from both sides. And when I rewrite it, I'm going to rewrite it in the order that I want to have it in. So 4x squared, and then my 14x and 10x come together to give me 24x. And I have a positive 35 minus 70 leaves me with a negative 35 equaling 0. So once I get to this point, right, I just use my quadratic. So my A equals 4, my B equals 24, my C equals a negative 35. So negative 24 plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. And I wrote that step out this time because those numbers are a little bigger, so I want to make sure that everybody stays on track with where we're at. So this is a negative 24 plus or minus the square root. 24 squared is 576. And then 4 times 4 is 8 times a negative 35, right? So negative and negative makes for positive. And then 4 times 4 is 16 times that 35, right, gives us 560. All divided by 2 times 4, which is 8. Okay, so at this point, that gives us a negative 24 plus or minus the square root of 130 1136, so 1136 all over 8. Now, I didn't tell you this at the beginning, but on this one we're going to do the decimal approximation. Okay, so we're going to go over how that works. Now, we're talking about the width, right, of this frame around an edge. If I do negative 24 minus another number, so I'm going to have a negative minus another amount, is that going to give me something that can give me a measurement? No, right? So we can ignore the minus. So the only one we actually have to look at is the negative 24 plus the square root of 1136 all over 8. So if you check this in your calculator for a decimal approximation, it gives you that it's 33.7. Okay, so if I do my negative 24 plus my 33.7 divided by 8, that gives me 1.21. So my x, which was my width, right, equals 1.21 inches. Now, that's an approximation, but that's very, very close, right? We just rounded it. So on the homework tonight, it gives express direction in each section. The first group you're supposed to leave in your square roots, in your your radicals, and then the second part of it you're going to use the decimal approximations to the nearest hundredth.